Okay, so as I was saying in problem number 2, what we're going to do now is we're actually going to work backwards. So we're actually going to find that greatest common factor, but we're actually going to pull everything out as we go through. Okay, so the first thing we're going to do is we're going to identify between 4x to the 5th minus 24x cubed plus 8x. We're going to identify what are the greatest common factors of that. So we're going to do the same thing. Now you can start to do this in your head as you pick up the traits of it. So real quick, I know it's x to the 5th. I know that's 5x's. X cubed, I know that's 3x's. Okay, and then x, that's just 1. So right there, I automatically know x is my largest. Now if that would have been x squared, then x squared would be your largest. Okay. Then I go down the list and I look for what's the greatest common factor beyond that. Okay, and this may be, another way would be to pull out the factor tree, and you could write up just the coefficients. I say, hey, 4 is 2 and 2, 24 is 2 and 12, which breaks down to 2 and 6, which breaks down to 2 and 3. And then I know 8 is 2 and 4, and that breaks down to 2 and 2. So you can do factor tree as well, since you already got the letters out of the way. And I notice, hey, they have a 2, that one has a 2, and that one has a 2. I notice that this one has another 2, so does that one, and so does that one. So there's actually 2 2's, which makes 2 times 2, which would be 4. Now I could see that with the 4, 24, and 8. 4 goes into 24, and 4 goes into 8, and obviously 4 goes into 4. So right there's what I have. Okay. Now as I go through, I want to fill in those spots. I know this is going to be negative. I know that's going to be positive. So I have 3 terms here because I had 3 terms up here. So what I'm looking for, if I pull out the 4x of this term, when I distribute back through, the question really becomes 4x times what gives me 4x to the 5th. Now the 4 is real simple. That's a 1. 4 times 1 makes 4. Then we go on to x, and we say, all right, x times what gives me x to the 5th. Now if you paid attention to the fact that we're going to add, this is a 1, so that means I need a 4 there. I need 4 more x's. Okay, so it's a 1, which we don't have to write, and then we have 4x times x to the 4th makes 4x to the 5th. Same thing next one. 4 times what gives me 24? Okay, that would be 6, and then x times what gives me x to the 3rd? Well, I need 2. 1, 2 makes 3. And then we go to 4x. 4x times what gives me 8x? Well, 4 times 2 gives me 8, and x times 1 gives me x. So right there's the idea of how we got that. And in terms of that, you're pulling that out, and if you want to check, then you got to put it back in. So a check would be to actually go through and say, what's 4x times this? What's 4x times that? And, well, missed it a little bit, 4x times that. Okay, once you do that, it should get you back to your beginning. If you don't get back to your beginning, it means you did something wrong and you go back and check it. Okay, so that would be your answer right there. Alright, so got it number 3. Go ahead and factor that out. If you have questions, let me know. Alright, so we look at story problems involve this. A helicopter landing pad, or a helipad, is sometimes marked with a circle inside a square so that it is visible from the air. So you can see over here on the left, I give you kind of a diagram, and that's again 482, I believe, is what page that's on in your book. So the question is, what is the area of the shaded region? So you can see the green shaded region. We want to know what that area is. The first thing we should do, as soon as we see a story problem, is analyze what we need. And they said area, so automatically I went to, hey, the area, well, I have 2 shapes. So I could say area of a square is the s squared, which would be side squared. It'd be length times width, but since we know it's a square, sides are the same. And then I go to, well, the area of a circle. And I say, all right, well, an area of a circle is pi r squared. Okay. So we get in that idea that pi r squared is the area of a circle. So I actually have to figure out what both shapes are, but this is kind of like a cookie cutter. You have a square shape, we're taking a cookie cutter, punching a hole through the middle, and what remains of the outside is what we're looking for. So if you think about that, what a cookie cutter does is it takes the dough on the outside, you punch that in, you remove it, what you're left with is what you need. So if you take that concept, we're going to take the area of the square and we're going to remove, which we see as being subtraction. Okay, so we're going to remove the area of the circle. Okay, so now we have something to go with. We're going to put s squared minus the pi r squared. Now we want to get some like terms, so we're going to put just put a big A here for our area. Well, we have everything here labeled as x's, so our side is 2x. So what I'm going to do is I'm going to write 2x squared, and I'm going to put that in parentheses because that's the side is 2x and the side's being squared. And then I'm going to put pi r, which is x, I'm going to put x squared. And as I simplify this, 2x times 2x is 4x squared. And then I have pi x squared. So really the circle kind of is the same thing, just replace it with an x. So right there is kind of the work we have. Now it did say write it in factored form. So what we're going to do is we're actually going to write this down into that factored form. So what I see is, hey, they both have x squareds, so I can pull out the x squared. That leaves me with 4 minus pi. And they didn't give us anything, so really we're just giving a general equation here or a formula so that, you know, maybe a designer, somebody who wants to generate that idea, they can quickly figure out, you know, maybe how much paint they need to paint that shaded region, or maybe they'll put gravel around there. They need to know how much gravel they need, something like that. Okay, so that would be your actual formula. And again, that's on page 482. You can kind of follow along with that. And then that it takes you into got it number 4, which is looking at a problem 4. Suppose the side length is 6x on the square, so the square has 6x, and then the radius of the circle, okay, is 3x. All right, and you can look back to that last slide and watch it again if need be. Okay, so there's your got it examples, answers. And if you have any questions, again, Edmodo or Twitter, let me know. And make sure you're taking your Edmodo quiz. All right, so have a good night.